Hi. Today I will discuss the solutions for the practice problems on subprogramming, okay, subprograms, and I'll go through the code of each of these problems. But I'll suggest that if you haven't tried them yourselves, please do that before you look at this video, right? So let's look at the first problem, okay, which asks you to write a subprogram that accepts three numbers through its formal argument list and returns their sum. Okay, so in terms of a black box type thinking, how would it look like? So you have a black box. It's called sum. It takes three inputs, right? Three inputs, which are three numbers, uh, and it returns one output, okay, which is the addition of these numbers. So let's say the numbers are 5, 10, and 15. The result would be the sum, which is 30, right? So it takes three inputs, and it has one return. Okay, so how would the function look like? Obviously, any function definition starts with the keyword def, right, which stands for define. Now you state the function name, let's call it add, right? And then because we have three inputs, right, we need three placeholders, right? We need three placeholders, right? One for each input, okay? And these placeholders are nothing but variables, okay? And these placeholders are actually, right, these are technically called formal arguments, right? Okay, so we have three placeholders. Let's call them a, b, and c, right? And then we have this column. And what we do here is we can say d equals a plus b plus c. Add them, right? Add these numbers, whatever the numbers are, store them in d, and then we can return d, right? So that is the definition of a function, right? That takes three numbers and adds there and returns their sum. Now because Python does not type check, right? Python does not check the type of these. If you send strings in there, it will give you a concatenation of the strings, right? A concatenation of the strings. So let's write a program and see how it looks like and how it works, okay? So we start with, as I said, the def keyword, which stands for define, right? And we define a function which we call add. The add function takes three numbers, right? There are three placeholders or three formal arguments, right? So I'll call them a, b, and c, okay? And inside the function we add these numbers, right? So we say d equals a plus b plus c, and then we return d, okay? There's another way of doing this. You don't have to have this temporary variable d. What you can do instead is you can just say return a plus b plus c, and that works as well. That works perfectly okay, right? Now how do we call this function? We can just say print, right? Let's say you want to call this function and print the value, right? Print the value of the print the sum of three numbers, okay? So what we do is we'll say print, and then we'll call this function add, and inside this add we'll pass three numbers, okay? We'll pass three numbers. The numbers are, let's say, 5, 10, and 15. And when we do this, when we run this program, it'll give you this 30, right? That's the sum of these numbers. Now because this add function expects three arguments, right? If you try to give more than three, it will create problems, right? If you try to give four, it'll say type error. It'll say add takes three positional arguments, but four were given, okay? So it expects three arguments, but you gave me four. so it doesn't work, right? Now same if you want to give, excuse me, or if you have to give less arguments than it expects, fewer arguments than it expects, it will complain again, right? It says missing one positional argument C. So I expected A, B, and C, but you gave me A and B, right? That doesn't work either. So the number of arguments that you promise should match the number of arguments that you actually pass, right? The other thing that we said was that Python does not type check, and as you know, the addition operator also works on strings, right? It actually also works on lists, so you can pass lists for all Python cases. Okay, we can say print add, and let's give it 3 strings, right? So let's give it 3 strings, and the strings are, let's say, hello and world, right? And maybe something else as well, maybe an exclamation, right? So when you do this, you run this, it'll give you 30, which is for the first one, right? And then it'll say hello world, right? Hello world exclamation mark, which is the concatenation of the 3 strings which were passed as arguments. Okay, now let's go back to our next problem. And the next problem says write a subprogram that accepts 4 numbers through its formal argument list and then returns their average. Okay, so it's very similar to the previous one, right? Except the number of input would be different, right? The previous one accepted 3 numbers, this one accepts 4 numbers, right? And also the previous one printed the sum or returned the sum, this one returns their average, which is the sum divided by 4 essentially, right? It's not different, right? So we will change this name because it's not add anymore, right? The name of the function should sort of hint towards what the function actually does, right? So I'll call it average. I'll call it average, right? And the function takes 4 arguments, so I'll say A, B, C, and D. And what does the function do? The function returns the average, right? So it returns A, B, C, D divided by 4. That's the average, right? So the average would be, let's say, print the average of 5, 10, 15, and 20. So I'll just say average, right? And I'll give it 4 numbers. So the 4th number I'll give is 20. Okay, and this will give me the average of these 4 numbers, right? So when I run this, it'll say 12.5, which is the average of 5, 10, 15, and 20, right? Now, just like before, we can pass different arguments. Like Python does not check if you pass a different type, like you can pass integers, you can pass floating points, which works. You can also pass Boolean variables. Python would fail, obviously, because hopefully it'll fail, because let's see this. Let's try this. Okay, you can say true, true, false, true, false, right? If you do this, let's see if Python complains. It doesn't. Well, so what happens is true is sort of inferred as 1 and false is inferred as 0. So if you pass true false, right, it's 1 0 1 0, so 1 plus 0 plus 1 plus 0, which is 2, divided by 4, which gives you 0.5. Weird, right? But this is done for legacy reasons. Okay, so there's an old programming language called C, and that's how C sort of interprets it. But anyways, so this I hope you find this interesting. But you can try with different types of data. So let's try strings as well. So let's try print average of hello, right? You know what? Doesn't matter at this point. Hello world and goodbye world. Okay, let's see if Python complains or not. At this time it does, right? This time it says type error, right? Unsupported operands, because A plus B plus C plus D, right, will give you hello world, goodbye world. That's fine. Python is fine so far. Python is fine, right? It'll say hello world, goodbye world. But then when you try to divide it by 4, Python complains. It says you're trying to divide a string by an integer and I cannot make any sense of it. Okay, but this is just just to maybe play around with this stuff. But this is where the program ends actually. So you have this definition of the function called average, which takes 4 numbers, and all it does is it adds these numbers and divides by 4, which gives you the average, and it returns the average. That's it, right? Let's look at the next one. So the next problem says or asks you to write a subprogram that accepts 3 numbers through their formal argument list and returns the greatest value. Okay, and we cannot use a max function of Python. So how do we write this program? We start with 3 numbers, obviously, right? We start with 3 numbers and think of it as a match. Okay, so you have 3 numbers. Let's call them A, B, and C. We don't know what the numbers are. Okay, we don't know what the numbers are. But what you're trying to do is akin to finding a winner. Okay, winner in a series. So we have matches between these numbers. Think of these as teams, right? So you have a match between A and B, and we want to find out who is the larger number, right? A and B has a match, and we find out the winner. Whoever the winner is plays with C. Okay, and the winner of this, the second match, would be the result, would be the greatest, right? So the idea is we have to have two comparisons. You can choose any order you like. You can have the first match between A and B and the winner gets to play with C, or you can have the first match between B and C and the winner gets to play with A. Either ways, right? You have two comparisons. So how do we do that? We can have like temporary variables. So I'll just say maybe we obviously start with def, right? Def, and then greatest. We'll call this greatest because that's the name of a function, greatest, because the max name is already taken by Python. Okay, so we'll call our function greatest, and the greatest will take 3 arguments, A, B, and C. These are the positional arguments, right? So in this case, if A is 5, B is 10, and C is 15, the first match, the winner of the first match would be B, which is 10. So this will give you 10. The winner of the second match will be between 10 and 15, right? And the result would be 15, right? So we define the function greatest, which takes 3 arguments, A, B, and C, and it gives you the larger of these 3 numbers, right? Now, how do you get the larger of these 3 numbers? Let's go with this analogy, okay? The series analogy, series of comparison, series of matches, right? So what we do is we define a variable winner, w for winner. Okay, now if I'll just say if a greater than b, then winner equals a, else winner equals c. So the first match is done, we have our winner. Okay, so winner will contain the value 10, right? Next, what we will do is we will say we'll have a next series of matches with C, right? So if C is greater than W, right, then you can just say return C, because clearly C is the winner, because C is greater than, or C wins with the winner of the previous 2, right? Else return W. Okay, so this is one way of doing it. The other way, obviously, and maybe slightly simpler, would be to just go with the brute force approach. Brute force, okay? And how is the brute force approach? How does it look like? The brute force approach is comparing everyone to like in the same single statement. Okay, so we'd say something like if a greater than equal to b and uh, and uh, and b is greater than equal to c, right, then we return A. Okay. Else if, right? Else if B is greater than equal to A and B is greater than equal to C, we return B. Else we return C, right? That's another approach. I'll call it the brute force approach. Brute force. Okay. But anyways, this works as well. So you can choose either approach, but the function, the Python function, will look like this. Okay. We'll have a def, obviously, and instead of 4 arguments, we'll have 3 arguments, right? And the name of the function would be greatest. That's the name of a function. Okay. And what do we do inside greatest? We say if A is greater than equal to B and and A is greater than equal to C, right? Then we return A, right? Else if B is greater than equal to A and B is greater than equal to C, we return B, right? Else we return C. That's it, right? That gives me the greatest of 3 numbers. Now how do we use this function? As usual, let's say we want to print the greatest number between 5, 10 and 15, right? So print greatest 5, 10 and 15. This would give me, when you run this program, this would give me 15, right? Similarly, you can use with other data types. So you can use it with floating point numbers, 5.1, 10.2 and 15.9. The answer would be 15.9, right? You can use it with strings. So we can say Zeus, Aries, and Hera, right? And this would give me Zeus, of course, because when we talk about strings, the lexicographically largest number, or not number per se, I'm sorry, string, the string which comes lexicographically later, right? So if you were to find these strings in a dictionary, the string that would come later would be Python considers that string to be a greater string, okay, so to be larger, right? That's how we define a relationship between strings. Okay, so that's what we do, right? So ZS would be further down in a dictionary, right? A's would be first because it starts with A, Hera would be next, and then it would be ZS. So the greatest of these 3 strings would give me ZS. You can also do true false, right? Obviously it doesn't make any sense, but let's try it anyways, right? True, false, maybe false again. Can you guess what the result would be? The result would be true, because as I said before, true is considered to be 1, false is 0. Okay, so the greatest of these would be true because 1 is larger than false, right? Right. Now let's look at the next one. The next one is pretty similar to the previous one. So it says write a subprogram that accepts 5 numbers instead of 3 like before. So it accepts 5 numbers through its formal argument list and displays the greatest value. Okay, so it's pretty similar to the previous program, right? But instead of 3, right, we have to find the greatest between 5 numbers. Okay, we have to find the greatest of 5 numbers. So obviously the function would take 5 arguments. So I'll have 5 formal parameters. Let's call them A, B, C, D, E. Okay, so we add D and E to this, okay, because it takes 5 numbers. So we need 1 formal argument for each number. Okay, now you know what, let's do the match way, the previous way that we told about. Okay, so let's do it this way. Let's say we have 3 numbers. Let me get rid of this. Let's say we have 5 numbers. So A, B, C, D, and E. So the first match would be between A and B to find who's greater. right? Whoever wins plays with C, right? Whoever wins plays with D, okay? And whoever wins this match plays with E, right? So that's one way of doing it, right? So we can have a variable called W, okay? And W stands for winner. So initially we'll assume A to be the winner. Winner equals A. I'll say winner equals A, okay? And then I will keep changing the value of winner based on who wins these matches, okay? So I'll initially consider winner to be A, okay? Now if between A and B, if A wins, winner stays A, right? So this would be A with C, right? And if winner loses, it would be B with C, right? The next match would be between B and C, right? So this would be our approach. So we'll have a variable called winner. We set it to A initially. We assume A to be the winner, okay? And then what we'll do is, if B is greater than A, right, then winner equals B. Or we can also say uh, if B is, for each of these, right, we can say if B is greater than winner, then winner equals B. If C is greater than winner, winner equals C. If D is greater than winner, winner equals D. If E is greater than winner, winner equals E, right? So if initially winner equals A, this is the winner, right? This is the winner. You know what? Let me clear the space. Okay, clear the space up so that it's easier to follow. Uh, initially A is the winner. That's my winner. Winner equals A. Now I play the match between B and whoever the winner is. So winner is A, right? Winner is A. So the first comparison is between B and A. The winner is A. I'm sorry. The winner is if B is greater, the winner is B. Else the winner is A. Right? So that's my new winner. I don't know who the winner is. I just know somebody between A and B must be the winner. Now next, the winner is compared with C. The winner plays a match with C. Right? That's my match. And whoever wins becomes the new winner. That's my new winner. I don't know who it is, right? But I just know that whoever the winner is must be the greatest between A, B, and C, right? Next, the winner plays a match with D. That's my match, right? Winner playing with D. And if D wins, D becomes the new winner. Else, the winner stays the previous winner, right? So at this point, whoever the winner is must be the greatest between A, B, C, and D, right? Must have won all the matches, right? Essentially, right? And then the winner plays a match with E, and whoever wins is the greatest number, right? Whoever wins is the greatest number between all 5 numbers, okay? So that's what we'll do, okay? Let's mix it up. So we followed the brute force approach before, in which we compared everything, right, in a single statement, but let's do it this way. So I'll say W equals A. So let's say the winner is A. Now if B is greater than winner, then winner equals B, right? Now if C is greater than winner, winner equals C, right? If D is greater than winner, right, winner equals D, okay? And if E is greater than winner, okay, winner equals E. And at the end of end of all this matches, all we do is we return the winner, return W. W is for winner, okay? So how do you find the greatest of 5 numbers? Let's call them greatest of 5, 10, 15, 20, and 25, okay? And when we run this, it gives me 25, right? Obviously you can try it with different numbers, or you can change up, you can mix and match, you can change up the order. So you can say 25, 10, 15, 20, and 2, right? This will give me This will give me 25, obviously. Let's call it 100, right? This will give me 100, right? So what happens is, if you go back to this, if you go back to this, right, what happens is, if we add these, if we set a to 5 and b to 10, c to 15, 20 and 25, right? The first match, b is the winner, so the winner equals, initially the winner equals a, right? Winner equals 5. Let's call it 5. The winner equals 5. Winner equals 5 initially, right? W equals a, winner equals 5. Now after the first match, winner is whoever wins that match, which is b, so winner would be 10. After the next match, 10 will play with 15, so the winner would be 15, right? At the next match, 15 will play with 20, winner would be 20, right? And the last match, winner will play with 25, and the final result would be 25, and that's what we would return, right? That's what we would return. Okay, right. Let's look at the next example, next problem. Okay, the next one says, do the following. Write a subprogram named findMin that accepts two numbers through its formal argument list and returns the lowest one. Okay, that's part one. Part two is, using the subprogram cited above, write a Python program that prompts the user to enter 4 numbers and then displays the lowest one. Okay, so how do we do that? Okay, let's start with the first part, which is write a subprogram which accepts 2 numbers and returns the lowest one. That should be simple. Should be simple, right? We call this smaller. So I'll say def smaller. That's the name of a function I'm giving. And I could have said min. Right? But just so happens that min is it shadows the built-in function min. Okay, Python already has a min. It's okay. Python won't complain, but it's not a good practice to do so. Okay, so I'll use lesser, and the lesser function takes 2 arguments, a and b, 2 numbers, right? And given these 2 numbers, it will return the minimum of these 2 numbers, right? And the minimum is, you know what, let's call it smaller. Sounds better for some reason. The smaller of these 2 numbers. Okay, the smaller of a and b. How can we find the smaller of a and b? We can say if a is less than b, return a, right? Else return b. That gives you the smaller of 2 numbers, a and b, right? So the first part is done. If you say print smaller of 2 numbers, let's say 110, 100 is one number, 10 is the other, it would give me 10, which is obviously smaller, right? If you say 1 and 10, it would give me 1, right? Okay, so that's the first part done. What's the second part? The second part says, using the subprogram cited above, write a Python program that prompts the user to enter 4 numbers and then displays the lowest one. So the subprogram that we're going to write now will do 2 things. First, it will ask the user to enter 4 numbers. Okay, it does not take the numbers through its formal argument like before. Okay, it has no formal arguments. It asks the user to enter 4 numbers and then displays the lowest one. Okay, so how will the new function look like? Okay, the new function, let's call it, it's more of a, no, it's more of a procedure, okay, than a function, because it does not return anything. Okay, if you look at this, it does not return, it just displays, right? It does not return. All the previous functions, right, they accepted the arguments, they accepted the input through their formal arguments and returned the result. Formal argument, return, right? Formal argument, return. Even this one, right? Formal argument and return. But this one, the next part, the second part of this, prompts the user to enter 4 numbers, right? Which is using the input function and displays the lowest one. So it's more of a procedure than a function. Okay, But since Python does not differentiate, we're going to use the same, obviously, same format, of course. And what do we call it? What is this? What do we call it? Enter phone numbers and display the lowest. I'll just call it lowest, okay? Lowest, okay? And lowest does not take any argument, Instead, what it does is it asks the user it prompts the user to give it inputs, okay? So I have phone numbers, but this time the numbers would be entered by the user. So I'll say a equals int input enter first number, right? That's my first number. And then I do this for phone numbers, right? I do this for phone numbers. A equals this, B equals this, C and D, okay? First, second, third, and fourth. First, second, third, and fourth. Right? Those are my phone numbers. Next, the next thing is it will have to use the previous subprogram, right? The subprogram that we wrote. Actually, you know what? This is find min. That's what our subprogram should have been called. So not smaller, but find min. Okay. Sorry, my bad. So this subprogram is called find min. So the subprogram called lowest, okay, the subprogram called lowest, which is the second part, will use the find min subprogram and find the lowest one. So how do we do that? We can use the match analogy. Okay, so we have phone numbers. We have 4 numbers, A, B, C, and D. Okay, now we have the find min function that takes two numbers and gives me the smaller of these two numbers, right? So just like before, think of the find min as, you know, having matches, right? So the find min can be considered as a match between A and B, right? I'll just say FM, which stands for find min. FM, find min. Whoever the min is, plays with the next guy, right? Plays with C. So right, so again, find min between the winner of this and C, right? And whoever the winner of this match is plays with D, right? And the winner is the minimum, right? So we can use the previous approach that we used for finding the maximum of 4 or 5 numbers. Okay, so we can do the same thing here. Okay, so what we can do is let's go to the program. How do we use the find min, right? So we have 4 numbers. We want to find the minimum. So let's say winner is A. Just assume that A is the winner. Okay, let's assume that winner equals A. Now you know what? We don't even need that. We can just say winner equals find min A, B, right? That's my first match. And then winner equals find min W and C, and winner equals find min W, D, and print lowest is W, right? And that's it. That's pretty much it, right? So what did we do here? We have 4 numbers, right? We have 4 numbers A, B, C, D, which the user gave us, and then we had a series of matches. The first match was between A and B. Whoever the winner was, W, played with the third team. So winner played with C. Whoever the winner was played with D, right? And the winner would be the one that we print, right? So in this case, winner obviously is the lowest, right? So whoever is the smaller number is sort of the winner, right? So at the end of these 3 matches, we get our final result, which is the minimum of all 4, the lowest of all 4 numbers. Okay, So let's see, let's run this program. Okay, so print lowest. Okay, let's say 1, 10, 20, and 30. Obviously the result would be 1, right? So when we run it, oops, lowest, I'm sorry, lowest does not take any arguments. I completely forgot about that. Lowest does not take any arguments, right? So we have to call lowest without any arguments, right? That's what it says. Lowest takes 0 positional arguments, but 4 were given, and I gave lowest 1, 10, 20, 30, but that was incorrect. So let's run it. Okay, lowest says enter first number, so let's give it 1, enter second number 10, third number 20, fourth number 30. The lowest is 1, obviously. Lowest is 1. Okay. Let's run it again with different numbers. First number 10, second number is 1, third number is 0, fourth number is 5. The lowest is 0, right? Okay, now let's go to the last one. I guess this is the last one, right? Yeah, it is. Okay, so the last one says write a subprogram named display menu that displays the following menu. And this is the menu you want to display. Okay, I'll just copy this because I'm going to use this, right? So write a subprogram named display menu that displays the following menu. Okay, so that is obvious. So let's go back to our Python, and what we want to do is we want to define a new function called display menu, and the function does not take any arguments. Okay, the function does not take any arguments. The function does not return anything. It does not return anything. Oops, that's bad. So sorry about that. So what we need to do is in this function we need to print these. Okay, print these. That displays the following menu. So print. Okay, so Python lets you do this, right? If you have 3 inverted commas, you can type in multi-line strings in Python, right? So if you want to display this, let's just call display menu. This will display this thing. Okay, pretty neat, right? So that's the first part, display menu. That's done. Okay, what's the next part? Write a subprogram that named meters to miles that accepts a value, right, in meters through its formal argument list and displays the message xx meters equals yy miles, where xx and yy must be replaced by actual values. And 1 mile equals this many meters, right? Okay, so meters to miles, it accepts meters and gives miles. Okay, so let's do that. So we have a new function called meters to miles. So def meter underscore to underscore miles, and it takes through its formal argument, right, through its formal argument list, the value in meters. Okay, so I'll just say m, doesn't make sense. I'll just say v for value in meters. Okay, and all it does is it displays the message xx meters equals yy miles, right? So you know what, let's call it xx. Okay, and what is yy? Yy equals so the value xx divided by this number, right? That's my distance in miles. So after I've calculated that, all we need to do is print xx meters, sorry about that, xx meters, and equals, right, yy miles. Xx meters equals yy miles, right? Cool. So what we do now is, let's test this. Let's say meters to miles, 100 meters. Let's try with 100 meters. And it says 100 meters equals this many miles. Okay, let's try 1000 meters, which is 1 kilometer. 1000 meters equals 0.6. It works, right? It works. So let's say 1600, 1.6 kilometer is roughly equal to 1 mile. It works. Okay, so the next part is done, right? This part is done. We have written a subprogram called meters to miles, okay, that accepts a value through meters and displays this. Next, we would write a subprogram named miles to meters that does the reverse. Right? So it's a yy miles equals xx meters. Okay, and again we use this number right here. Okay, so what we do is def miles to meters takes yy, right? And it says xx equals the distance in meters, distance in miles times this number, and it prints, what does it print? Yy miles equals xx meters. That's what it prints. So it prints yy miles, right? Yy miles equals xx meters. That's what it prints. Okay, so let's test this one as well. Miles to meters, 1 mile, right? What's 1 mile? 1 mile is this meters, obviously. It's obvious, right? 100 miles would be a huge number, obviously, right? So this much meters. Okay, so our three subprograms are done. Okay, these 3 subprograms are done. Now the fourth one says, using the subprogram cited above, write a Python program that displays the previously mentioned menu. So I'm going to display this menu. Okay, prompts the user to enter a choice of 1, 2, or 3 and a distance. Next, the program must calculate and display the required value. Right? The process must repeat as many times as the user wishes, given that 1 mile is this. Okay, so there are a few things in this program. Okay, firstly, you might have noticed that it says the process must repeat as many times as the user wishes. So there must be a loop somewhere, right? There must be a loop. And if you encounter a statement like this, sort of you have to understand that, sort of infer that there is a loop somewhere. And in such scenarios, it's most common to do while loops. Okay, so I'll say there is a while loop. And how does the while loop look like? It says while, I'll just say while true. Okay, that's a while loop. And I'll do all that stuff here, right? I'll just say do stuff. And then once you're done with that stuff, you'll ask the user, right? You'll say input, you'll prompt the user to say, do you wish to continue? Continue, right? And I'll say yes or no, y/n, right? Do you wish to continue? Yes or no, right? And I'll store the response in a variable called response, response. I'll store the user response, and if response is equal to no, then I'll break out of this infinite loop. This is an infinite loop, right? Because it says while true, so it keeps on running until the user responds with an n, and then at that point I break out of the loop. Okay, so that's my loop done. That's the outside of my loop, that's done. So this do stuff, that's the thing that we need to take care of. Okay, so what is this do stuff? Using the subprogram cited above, which is display menu, meters to miles, and miles to meters. Okay, write a Python program that displays the mentioned menu right? And prompts the user to enter a choice of 1, 2, or 3 and a distance. Okay. Oh, hold on a second. There's already this exit. I completely ignored that. There is this option to exit. Sorry about that. Forget this stuff. Okay. While true, forget this stuff. So while true, the first thing we do is we display the menu. We display the previously mentioned menu and prompts the user to enter the choice 1, 2, or 3 and the distance. Good. The first thing we do is inside the loop, we call display menu. Done. Okay. Next thing is we prompt the user for a choice. Prompt the user for a choice. So I'll say choice equals input, enter your choice. Enter your choice. It can be 1, 2, or 3, right? It can be, you can also say 1, 2, or 3. Your choice is 1, 2, or 3. And that's my choice. The user will enter the choice. Now I'll say if choice is equal to 3, then we break out of the loop. Break out of that loop, right? I don't need this parentheses. Don't need this one. Okay. So if the choice is equal to 3, I break, right? Else if the choice is equal to 2, if the choice is equal to 2, by the way, I'm using strings, right? Because I did not convert this to an int. I could have done this as well, right? But it doesn't make any difference. It doesn't make any difference, okay? If I were to do this, I could have used numbers instead, okay? But essentially, you can go either ways, okay? Anyways, so if the choice is 3, you break because the user wants to exit, obviously, right? If the choice is 1, you convert meters to miles. So the next thing you do is let's say x equals int input enter value in meters, right? Enter value in meters. Okay. And when the value is entered, all I do is I say meters to miles and then press X, pass X. Okay, meters to miles. I call this function and pass the number that the user wanted, right? Meters to miles X. That's done. Else if choice is 1, if the choice is 1, I say again, I can say X equals enter value in miles, X equals enter value in miles, and I'll say miles to meters X, right? Finally, if the choice is neither 1 nor 2 nor 3, I'll print invalid choice, and the program will continue running. Okay, because the only way to break out of that program is to choose 3. Okay, so let me run this program. Let's see. Let me run this program. Okay, so this is my menu: convert meters to miles, right? Convert miles to meters, exit, enter your choice. Let's say I choose 1. Enter the value in miles. Yes, 100 miles. 100 miles equals this many meters, right? That's you know what? This would be miles, meters to miles. 1 would be meters to miles. 1 would be meters to miles. There's a slight mistake. It's not a deal breaker, but when choice is 1, I do meters to miles, and when the choice is 2, I do miles to meters. Okay, choice 1 is meters to miles. All right, let's run again. Convert meters to miles. Yes. Value in meters, 1000, 1 kilometer, which is equal to 0.62 blah 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 miles, right? That's my first choice. Try again. Let's try this one. Let's try meters to miles again. Okay, choice 1, value in meters, 10,000 meters or 100,000. That's my miles, 62 miles, right? Enter your choice. Let's choose 2 this time. Value in miles, 2 miles. Okay, and 2 miles equals 3218.688 meters. Okay, that's my value in meters. Again, so as you keep going, right, you keep going, and it will keep on asking about, you know, your choice, and based on your choice it will ask you about the numbers, right? So enter your choice. Let's choose something weird. Okay, let's choose 0, and it'll say invalid choice, right? If you keep on choosing weird numbers, it will give you invalid choice. 100, invalid choice, right? 4, invalid choice. And if you want to exit, just press 3, and at that point the program stops. It says finished with exit code 0. Okay, so that was it. That was all the programs in this uh, problem set. If you have any questions, let me know, and I will post the list practice problem solution soon. Right? Bye.